A good enemy is really three behaviors: patrol, detect, and chase. It wanders until it spots you, then hunts you down. Let's build 2D enemy AI in Godot 4, state machine and all. One honest heads up before the code. If you are learning Godot and you want a map instead of a maze, I put together a game dev starter kit. $19, and it is a 30-day roadmap plus Godot and Unity cheat sheets, code snippets, and an engine guide. It is completely optional, and the link is in the description. Now, let's build the enemy. Before we touch code, here is the whole plan on one screen. Almost every 2D enemy you have ever fought is built from the same three behaviors. Behavior 1 is patrol. When the enemy has not seen you, it just wanders, back and forth between a couple of points, minding its own business. Behavior 2 is detection. Every frame, the enemy checks how far away you are. Step inside its range, and an alarm goes off. Behavior 3 is chase. Once it has spotted you, it stops patrolling and comes straight for you. Now here is the part that ties it together, and it is the single most important idea in game AI, a state machine. The enemy is always in exactly one state: patrolling, or chasing. Nothing in between. Detection is the switch. Player in range, flip from patrol to chase. Player gets away, flip back to patrol. That is the entire brain. We built a full state machine in the Godot video on this channel, and the idea is identical here. One enemy, a couple of states, clean code. Let's write it, one behavior at a time, starting with the chase. Let's start with the most satisfying one, making the enemy follow the player. In Godot 4, this is basically one line, and it is beautiful. Here is the enemy script, and it extends character body 2D, Godot's node for anything that moves and collides. Up top, an exported player reference, that is who we chase. And an exported speed, so you can tune it in the inspector. Now the magic, inside physics process. We call global position.direction to, hand it the player's global position, and get back a vector pointing straight at them. Multiply that by speed, store it in velocity, then call move and slide. Direction to always returns a length 1 vector, so the enemy moves at exactly your speed, in the right direction. And in Godot 4, move and slide takes no arguments. It simply reads the velocity you just set. Every frame, the enemy glides toward the player. One question: where does player come from? You can drag it into the exported slot in the inspector. Or grab it in code with getTree, get first node in group, passing player. Either works. A common trap, though. Forget to assign that reference, and you get a null the instant the game starts. Fill the slot, or put the player in a group and fetch it. Now the enemy follows, but from anywhere on the map. Let's give it eyes. An enemy that chases you from across the entire level is not smart, it is annoying. Real enemies only react when you get close. That is detection. The tool is dead simple, global position.distance to. You hand it the player's position, and it gives back how far apart you are, as a single number. Here is the check. We compare that distance to a detect range, say 200 pixels. If the distance is less than the range, the player is close enough to notice. If not, the enemy has no idea you are there. Picture a circle drawn around the enemy. While you are outside the circle, it keeps patrolling, totally unaware. The moment you step inside, detection fires, and it switches to chasing. That circle is your detect range, and you can make an enemy jumpy or oblivious just by changing that one number. Want to be fancier? Instead of a raw distance, you can drop an area 2D on the enemy and react to its body-entered signal, or cast a ray so the enemy cannot see you through a wall. But for most 2D games, a distance check is all you need. Start simple. Right now, when the enemy is not chasing, it just stands there like a statue. Let's give it somewhere to go, a patrol route. The setup is an exported array of marker 2D nodes, the waypoints. Drop a few markers around your level where you want the enemy to walk, and drag them into the array. We keep one integer, the index of the point we are currently walking toward. It starts at 0, the first waypoint. Inside the patrol function, we do the same direction to trick, but the target is the current waypoint instead of the player. The enemy steers toward it at a calm patrol speed, and we call move and slide. Then the key step. Each frame we check the distance to that waypoint. Once we are close enough, within about 4 pixels, we advance to the next point. There is a clean little trick for looping. We take the current index, add 1, and wrap it with modulo the array size. When the enemy reaches the last waypoint, that wrap sends it right back to the first, and it patrols forever. No if statements, no manual reset. Now we tie the two behaviors together, and this is where it becomes real enemy AI. The state machine. At the top of the script, we declare an enum state, with 2 values, patrol and chase. Then one variable to remember which state we are in right now, starting on patrol. Physics process becomes a match on that state. In the patrol branch, we call patrol, and then we check, is the player in range? If yes, we flip the state to chase. In the chase branch, we call chase, and we check the opposite. If the player is no longer in range, we flip back to patrol. Read that out loud and it sounds like a living thing. Wander around. See the player. Give chase. Lose them. Go back to wandering. That is the whole loop. This is the pattern professional games use, just scaled up. 2 states today. Tomorrow you add attack, or flee, or search, each one is another branch in the match. The structure never changes, it only grows. That is why a state machine keeps enemy code clean instead of a tangle of booleans. And because each state is isolated, a bug in your chase logic can never break patrol. That separation is the whole reason this pattern scales. 2 small touches take this from functional to feeling good. Polish. First, the enemy should face the way it is moving. Right now it might chase you while facing backwards, which looks broken. The fix is to flip the sprite. Check whether the target is to the left, and set the sprite's flip H to match. Now it always looks where it is going. Second, stopping distance. If the enemy chases all the way to your exact position, it shoves into you and jitters. Instead, only move while the distance is greater than a small stop distance. Once it gets that close, it holds, right next to you, ready to attack, not vibrating on top of you. Add those 2 and the enemy reads as deliberate instead of robotic. And that attack, swinging when it is in range and dealing damage, is the natural next state to build. It slots right into the match as one more branch. The written guide below walks through smarter pathfinding too. Let's lock in what you built, because this is the real pattern. An enemy is 3 behaviors. Patrol, walk between markers with direction to and move and slide. Detect, compare global position distance to against a range. Chase, steer toward the player, every frame. A state machine holds it together. 1 enum, patrol or chase. Detection is the switch that flips between them, in a simple match inside physics process. And 2 bits of polish. Flip the sprite toward movement, and stop just short so it does not shove into the player. That is a complete, clean, extendable 2D enemy in Godot 4. That is 2D enemy AI in Godot 4, patrol, detect, chase, and a state machine to run the show. You now have the exact skeleton real games build their enemies on. Here is your next move. The full written guide is on screen and linked below, with proper Godot 4 pathfinding, a navigation agent 2D that routes the enemy around walls on a real map. And do not stop while it is fresh. Your next watch is lined up, the Godot state machine build, where you turn this pattern into a clean, reusable system. Or see the exact same enemy built in Unity, if you work across both engines. If you want the full 30-day plan, the Game Dev Starter Kit is in the description. Subscribe for more beginner Godot tutorials. Now go make something chase the player. See you in the next one.